Today's lesson is on proofs about perpendicular lines. We'll look at how to find the distance from a point to a line. We'll look at how to prove theorems about perpendicular lines and solving problems including or involving perpendicular lines. We'll work on constructing perpendicular lines in class. Our first theorem, linear pair perpendicular theorem, tells us if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. The perpendicular transversal theorem tells us in a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. The lines perpendicular to a transversal theorem says, in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Our first example is finding the distance from a point to a line. The shortest distance is always the line perpendicular from the point to a line. So we're going to simply use the distance formula and review the distance formula, which will be from point A to point D. So I'm going to use the coordinates of point A, which are at -1, +8, and the coordinates of point D, which are at -4, +2. So I'm going to find the length from A to D. We'll set up our distance formula. We're going to take x2 minus x1, -4 minus -1, which becomes plus a +1 squared, plus y2 minus y1, 2 minus 8 squared. Simplify. AD equals square root of -3 squared is 9, plus -6 squared is 36. 9 plus 36 is the square root of 45, which is approximately 6.7 units. For our second example, we're going to prove the perpendicular transversal theorem using the diagram and alternate interior angles. We're going to start with our pieces of given information. We're given by the picture that we have lines parallel, which are H is parallel to K. We're also given by the picture that line J is perpendicular to line H, and we're going to prove then that J is perpendicular to K. We'll make our two columns for statements and reasons. We'll start with our given information. H is parallel to K and J is perpendicular to H. You can write them as one given or two separate givens. Always identify your given information first if you're looking at a proof. We know that the measure of angle 2 is 90 degrees. That's our little box up at the top up here. That's definition of perpendicular lines. They make right angles. So I'm going to abbreviate so I have room to write it on here. We know that angle 3 is congruent to angle 2. Those are vertical angles. So I'm just looking at things that I know from the picture. Vertical angles are congruent. We know that angle 3 is congruent to angle 6. They want us to use alternate interior angles. So we're going to put angle 3 is congruent to angle 6. And those are alternate interior angles theorem. Or you could just say alternate interior angles congruent. I'm going to abbreviate. We know that angle 2 is then congruent to angle 6. And that's by the transitive property of congruence. We know that measure of angle 2 then equals the measure of angle 6. And that's definition of congruent. We're saying they're congruent is the same as saying equal. We then know that the measure of angle 6 equals 90 by the transitive property. I'm going to write the rest of them up on top here. And therefore J is perpendicular to K, and that's the definition of perpendicular lines. Our next example says the photo shows a layout of a neighborhood. Determine which lines, if any, must be parallel in the drawing and explain your reasoning. So they're a little hard to read, the letters, but there's a line P and Q on there. There's also a line S and a line T on there that we'll work with. So we know that from the picture that line P and Q are both perpendicular to line S because they show the little boxes on the picture there. So we know that line P is perpendicular to line S. We also know that line Q is perpendicular to line S. So by our lines perpendicular to transversal, P is parallel to Q. Also we know line S and T are both perpendicular to Q. So again, by the perpendicular to transversal, S is parallel to T. So then this was our perpendicular to a transversal theorem. In our last example, the diagram shows a layout of walking paths in a town park. Determine which lines, if any, must be parallel in the diagram and explain your reasoning. So by our picture, we know that A is perpendicular to D and line B is perpendicular to D. And we know that line A and B then are going to have to be parallel because A is perpendicular to D, and B, perpendicular, not parallel. And we know that B is perpendicular to D, so we know A has to be parallel to B, and that's lines perpendicular to a transversal theorem. And that's our notes for today.